So control and circuitry decisions, this represents the C of our framework. And these decisions cause some of the biggest problems I've seen in installations. So circuitry is a key component of planning your installation. Considerations such as wire sizing for power requirements and sleek installations must be considered. So what does that mean? We have to manage voltage drop. We have to confirm if we're using a constant voltage LED system or a constant current LED system. So voltage drop can happen in the wiring. The wiring amperage could increase as a loss of voltage. You have to understand all these parameters, and then you just don't want to use the biggest wires. I hear some people say, let's just use the biggest wires, and then when they have to integrate onto the LED in a very fine detail, there's this chunky wire that could barely integrate into a small LED system. So all these wiring considerations need to be accounted for, especially in tight spaces or sleek installations. Then control systems are often added to LED linear lighting installs to improve flexibility and user experience, but they can also become one of the least visible sources of long-term problems. The issue isn't the circuitry and the control itself, it's just the poor planning that impacts the long-term solid installation reliability. Many installs work perfect at handover, only to develop flicker, inconsistent behavior, or driver stress months later. So for example, an LED driver may be under distress, but it wouldn't show up right away. It's going to show up a few months after or even a year after. I've had some really reliable transformers, and even though we underspec the power supply, I don't know where it happened, but it still ran for a very reliable time just because it was a very high quality product. So many installations work perfectly well at handover, but they will develop eventually flicker, inconsistent behavior, driver stress months later. These problems are often blamed on the product when in reality it's because they're caused by bad decisions that we didn't account for in real world usage, such as the commissioning quality and the long-term stability. So this lesson helps you recognize when controls are helping and circuitry is helping and when they're quietly increasing risk. So the common red flags that you need to look out for are: one, control mismatch. So dimming and automation protocols are not matching the strip or the driver. So some people assume because an LED strip is low voltage that it's dimmable. That's not the case. Some LED strips have ICs, integrated circuits in it, that if you try to dim it, it's not going to dim. So another thing is overclocking the maximum amperage of products. So you have control products and they have a maximum amperage or wattage it could handle. And I've seen this commonly where designer tries to do engineering and the LED specifications, and they put 200 watts of LEDs, and then they're telling you they want it dimmable on one switch. So the switch now says that it could only dim 150 watts. So now you're stuck trying to explain to the designer, we can't dim this because the switch is going to overload. But I've seen it time and time again where nobody knows, electricians don't know, they follow, they all go through with it, and then I have the customer coming to me because nobody could solve the problem. My switch is broken. Why is the switch broken? Why this is going on and that is going on? And then, it used to be really frustrating because we were the problem solvers in the business at one point. And it was good being a problem solver. It was just a little annoying, but we had to explain that everything was overloaded and what could we do? Oh, well, you have to rewire here and you have to use two dimmers. And they're like, what? I have to open the ceiling. I have to do this. So understanding these red flags are going to save you a lot of time and stress, and you're going to make excellent decisions and not just depend on what was given, because that's the biggest scapegoat. I hate to hear electricians say, that's what you did. That's what was specified. That was what I was given. That's not my job. Well then, don't be an electrician if you're not going to know all these things. Get another job. Honestly, if you're in this field and you don't know these things, and LED lighting is the future, and you don't know these red flags, then don't be an electrician anymore. Sorry to say it. And that's coming from a point of frustration, seeing the sloppy and terrible work in the market space. So guys, let me continue. Controls chosen before application is clear. So control decisions are made early, and the application and usage has been defined later. So you need to know what's going to work. Circuitry mismatch. So electricians often treat wiring as 120, 240, and they may make mistakes, or they just follow the simple, I'm allowed to use low voltage wire once it's under 96 watts and 24 volts. That low voltage wire could be 200 feet away from where it's supposed to be. Or what I see commonly is electricians putting drivers all over the place, by the closet and here and all over the place, and they're not smartly designing. And when you have a high-end luxury home, people don't want you in their personal space. So you want to put it in some service areas. They don't run the calculations. They just say 96 watts, 24 volts, or 60 watt, 12 volts. I could put a low voltage wire, and they think it's all going to last well. But there's burnout. The LED is underpowered, doesn't get the right voltage. A lot of things happen. So yeah, circuitry mismatch. Again, wires cannot easily integrate into detailed spaces if they use a big wire just to compensate. So another red flag is just, again, poor circuitry planning. So wiring not correctly mapped to minimize voltage drop, and voltage drop calculations not considered. So I'll put these points up on the screen, sorry, so it's a little clearer. And I think including the ramble is good, so you know how passionate I am about getting this information to you. So the key insight here is that every complex LED lighting installation project requires a thorough analysis of circuitry planning and control planning. So on your next job, I want you to ask the following. Am I planning the correct wiring layout and wire sizes needed? Who's responsible for commissioning and the long-term behavior? Are all of my controls compatible with the products, dimming protocols, and maximum amperages? I'm going to give you a brief overview of the wiring required for a kitchen, which is a common example in our full course, the Ultimate LED Lighting course. So this is just a brochure I'm showing from our company, and I'm going to show you what I mean by wiring and control. So what we usually do is plan and label our lighting. So we have area 1 in green, that's here, area 2 in purple, that's here, area 3 in here, that covers this space here, and in this yellowish orange color, area orange, which covers these lighting here. And you could see that we've named our lighting fixtures, we've named our transformers, where they're going, our power supplies, and we've named our controls. So you can see like a receiver is going here. So understanding the wiring pathway is showing that we're placing this transformer, this power supply or LED driver on top of here, and we're probably pulling it through the cabinetry and here, through the cabinetry and here. Now if this was a new job, you could probably put it in conduits and get it in nicely to come out exactly where the light is going to go. Then you could see that there's probably a plug on top of here, and it's going across in the wall to this side, and it's all tied back into a switch, which is the AC current right here. And you can see that switch is also going to be controlling this power supply or LED driver at the bottom here. And you can see the wiring pathways. Then this one is not connected, so there's a receiver added onto this one, and you have this wireless, I guess, control like up here. So it's just showing different types of switches, the circuitry, how everything is being run. And you could see that we have probably some small guidance in this brochure, and we're actually saying how to use the models. And this goes back to the brightness section. So it shows the series, Lumitrack, HR stands for high resolution, and when do you need to use the right brightness. So it's saying the HR30 series, it's for low brightness, small shelves, toe picks. The HR60 series is for medium brightness, and the HR90 series is for high brightness, ceilings, long hanging clothes. This is the Kelvin scale that's being used here. So that's all covered under brightness to understand when to use the correct CCT. Again, that's going to be covered in the full course, and we'll talk about Kelvin temperatures and the impact they have on spaces. And here we talk about the brightness per meter or foot and the wattages, so they know. And it's a small note. You could see here, maximum serial connection. This is something you have to be aware about in your LED linear lighting products. So maximum serial connection is up to 8 meters or 26 point. This model, it's up to 5 meters or 16 feet. And this model is up to 3.6 meters and 12 feet. and you can see how the brightnesses change. So understanding your product, understanding brightness. So understanding your product, understanding brightness, understanding how to put your layouts for controls, wiring, and circuitry, and how to conceal them. These are all the factors that are going to ensure that your LEDs last a lifetime. And that's the purpose of this mini course, to teach you that framework. So we've covered A, application, B, brightness, C, control and circuitry. And now let's move on to design details that affect a job long term.